5.3, this section, Shabab, is the first section about trigonometric functions. We have studied in the previous class the trigonometric ratios. Today we will see together, inshallah, what are the trigonometric functions of angles and how to evaluate them for any angle. This is, of course, the most important part. This will be, inshallah, next class, not today. So before starting, Shabab, let me remind you about what we did in the previous class. What we had in the previous class, we have a right triangle. We have this angle theta. This is the opposite adjacent hypotenuse. You know, we have defined, of course, sine theta to be what, for instance? What is it, sine theta, Shabab? Do you remember? It is the opposite over the hypotenuse. And similarly, cosine theta is the adjacent over the hypotenuse. And what you need to also remember more, the tangent only. Tangent is what is the opposite over the adjacent. I know, ya Shabab, that tangent is sine over cosine, but it is important to recall this ratio because what we are going to use heavily, like this, for example, and you have this is x, this is 3, and this is theta. Here you need tan. You need tangent, and here it is x over 3. So it is important to remember how to use tangent as opposite over adjacent. Now, what is the problem? Why we need to study more? Now, the problem, Shabab, is what? Let me also ask you something. Let me ask you here. And let me ask, start with who, for example? Let me ask with Ahmad Al-Attar, as he today here. Ahmad, what is the sine 30 degrees?
Half.
It is a half. And this is equals to what, ya Ahmad? The sine of 30 is the same as cosine of what?
60.
You are right. You are right. Yes. So sine 60. Similarly, cosine 30, which is square root of 3 over 2, is the same as sine 60. Thank you. Now let me ask Jawad. Ya Jawad, are you here?
Yes.
What is the angle that its cosine is the same as its sine? It has the same sine and the same cosine. What is this angle?
60.
No, sine 60. Sine 60 is this, and cosine 60 is this. I'm talking about the same angle, the same theta.
Very maybe. I don't know.
We have mentioned this in the previous class, Shabab. Who can say what is it?
45.
45, Shabab, 45 degrees pi over 4. It is the only angle that its sine is equals to its cosine, and it is equals to what? Square root of 2 over 2 in 1 over square root of 2 if you want to use it. Okay? And also you know what is sine 0 and cosine 0. And we know, ya Shabab, for these angles 0, 30, 45, 60, and 90. Now, all of these, ya Shabab, can be, of course, when the angle is between inside a right triangle, it is not a problem. But the problem is, what about if you have angle like this, 135? How to find its cosine? This angle is bigger than 90. Okay, so it cannot be drawn here. If you have, how can you draw? Who can draw a right triangle with angle equals to 135? Can you do that? We cannot, ya Shabab. There is no angle in the right triangle greater than 90. Impossible, or even equal. We have only one angle that is 90. The others must be less than 90. So how to deal with this problem? We have only opposite adjacent. So in this case, this angle cannot be fit inside an angle because it is not acute angle. Only we can deal with acute angle. So what is the solution for this issue? We will try to generalize the idea of the trigonometric ratios to be trigonometric functions. How to do that? The idea is so easy. Take this triangle, put it on the XY plane such that the vertex of the angle theta, it is at the origin. Okay? Now, this is the terminal side, Shabab, of the angle. We mentioned this in the previous class. This is the terminal side. and this is the initial side. Now take any point on the terminal side, this point or this point or this point. Let's take this, okay? Now, since this point, it is in the XY plane, it has two coordinates, the X coordinate and the Y coordinate, X and Y. What is X? X is this vertical horizontal distance, and Y is this vertical distance. So in this case, Y is what? Y is the opposite, and X is the adjacent. And this R, what is R? R is the distance from the origin to the point, the distance from here to here. R, of course, is always positive because it is a distance. R here is the hypotenuse, okay? I think this is clear. Now, according to this new notation, we can say what? What is sine theta, ya shabab? What is cosine theta? Who can tell me from here? According to that, what is sine theta? What is cosine theta, ya shabab? Hello? Opposite?
Y over R.
Y over R. First of all, what is R? R by Pythagorean theorem, it is x squared plus y squared under the square root. And it is always positive. Sine theta, it is y over R. Please, ya shabab, be active. Wake up. Cosine theta will be what? Will be x over R, the adjacent over the hypotenuse. So, and tan theta will be y over x. So, someone of you, he said, so what? So what? What is the difference? It is the same as before. Yes, it is if the angle in the first quadrant. But if we have, for instance, angle like this one now, this angle, it is in the second quadrant here, this angle. Now, this angle cannot be drawn inside. Theta here, it cannot be drawn inside a right triangle. So in that case, we don't need a triangle here. So what we will do, we will take just a point here, X and Y, on the terminal side of this angle, and we will calculate the distance from here to here, which will be R. This distance from here to here will be R. This distance, the horizontal distance, will be X in the absolute value of X, let's say. But here we will just put it like X, and this is like Y. Now you can apply the generalized idea by the same way. But indeed, you don't need to draw triangle at all. Just you will say that sine theta, it is Y over R, this is Y, and cosine theta, it is X over R, and that's it. So in this case, ya shabab, we have this definition for the trigonometric functions, and you know the definition of a function, what we mean by a function. So let theta be an angle in the standard position. You know what we mean by the standard position. The vertex at the origin, the initial side is the positive x-axis, the terminal side anywhere could be. If X and Y is a point, it could be this point or this, whatever it is. So it is just a point on the terminal side. If R is the square root of X squared plus Y squared, is the distance from the origin to the point, then sine theta is Y over R. Cosine is X over R, tan is Y over X. Now these are just the reciprocal. This is the reciprocal of sine, the reciprocal of cosine, the reciprocal of tangent. And of course, ya shabab, because X can be zero, it could be zero. For example, if we are on the y-axis, X can be zero. So to avoid this, we should say that X is not zero, Y is not zero, X is not zero, Y is not zero. R cannot be zero because it is the distance from the origin to the terminal point. Okay, what else now? What else we need to know is that for some angles, like 0, 90, pi, 3 pi over 2, we call these, ya shabab, quadrantal angles when they are on the y-axis, like this angle, for example, 90 degrees. This angle here, it is on the y-axis. This is the y-axis. This is the x-axis. Now, who can tell me if I take a point here, what will be the coordinate of this point? It will be 0 because x here is 0. And let's say y, whatever. Y could be 2, 3, 4, 4, whatever. Now, what is, ya shabab, sine 90 degrees? Well, what will be sine 90? Let me write it here.
1.
First of all, what is x? We have here, what is the point? 0 and x. So sine 90 degrees will be what? Will be y over r. What is r, ya shabab? R is what? Is the square root of x squared plus y squared. What is x here? It is 0. So it will be just the absolute value of y. What is y? The absolute value of y squared, it is y. Because we are in the first quadrant, let's say we are in a positive y axis. So here, this will be y over y, which will be 1. Sine 90 is 1. And cosine 90 will be what? X over r. What is x? X is 0 over y, which is 0. So now we know that sine 90 is 0 and cosine 90 is 0. So in this case, ya shabab, what will be tangent? What will be tangent of 90? It will be sine, it will be 1 over, it will be y over x. So it will be y over what? Y over 0, which is undefined. So we don't have tangent for 90. So this is why I should mention here that some trigonometric functions are undefined. For what? For quadrantal angles, for these angles. You can just check the table of the trigonometric functions to know that. Now, to evaluate about the trigonometric functions of any angle, you need to know the signs, where it is positive, where it is negative. All we know, Shabab, that this is the first, second, it is in this way. The order is like this, counterclockwise, 1, 2, 3, 4. Now, in the first quadrant, X and Y both are positive. بالنسبة للR يا شباب, الR is always positive, no problem at all. This is not an issue. Now, in the first quadrant, X and Y are positive. In the second, what is negative? X. In the third, they are both negative. In the fourth, Y is negative. Okay? Now, let's remember the function now. You remember what is sine. Sine theta, it is Y over R. So in the first quadrant, all of them will be positive because everything is positive. So all the functions will be positive in the first quadrant. Now, what will be negative in the second, Shabab? What is negative is X. So this will be what? Negative. This will be negative. What about this one? Is it going to be negative? Yes. So let's focus on what is positive. It is easier. So what is positive here, Shabab? Y. So this will be positive. And the reciprocal, this will be positive. These are positive. This one, of course, it will be negative. This negative, this is negative, this is negative because X is negative. Okay? So what is negative, Shabab, in the second, what is positive in the second quadrant? Sine and its reciprocal and cosecant. In the third quadrant, what will be positive, Shabab? What will be positive in the third quadrant?
Tangent.
This one, Shabab, because you will have negative over negative, positive, and also its reciprocal. So these will be positive in the third. So tangent and cotangent. The remaining will be negative. In the fourth, y is negative. So in the fourth, y is negative. This is negative. This is negative. In the fourth quadrant, what is positive? We are looking for what is positive. This will be positive and this will be positive. X is positive. For anything containing y here, it will be negative. So what is positive in the fourth quadrant? Cosine and secant. So shortly, we can put it in this table like that. What is positive is here, what is negative is there. Or we can just write it in short like this. With all the respect to Mobili and Zain, we can say all STC. All sine, tangent, cosine. And of course, in other words, you can say all students take calculus. All students take calculus. Or let's say all students take chemistry if you want to say. ASTC. Now, the second kind of problems that we will deal with, Shabab, is this kind of problems that is in fact not mentioned in your book and as an example, but as an exercise. So this is why I brought here many exercises, because it is repeated in all the exams. If the terminal side of an angle in standard position passes through the point 8 and 15, where is this point is in the quadrant? In the first or in the second or in the third, where it is? X is positive, Y is positive. So here we have X equals to 8, Y equals to 15. So it is where? It is in the first quadrant.
The first.
So what you will do, you will just determine what is X, what is Y. Clearly it is in the first quadrant. If you want, no need, by the way, but just if you want to have an idea about it. Now just you need to find R. This is R. Simplify. R is 17. Now what you want? You want to find the values of the 6 trigonometric functions. Easy. So sine theta. Don't remember opposite adjacent. No need. It is Y over R. What is Y? Y is 15 over R, which is 17. That's it. If you wanted to draw a triangle, it's okay, but no need. This is now the generalization of the definition. We are now dealing with them as functions, not necessarily angles of triangle, right triangle. Cosine theta, it is X over R. This is X and this is R. Divide. Tangent will be Y over X, 15 over. Now for the others, no need, of course. You can, of course, just take the reciprocals. Now another example, the terminal side of an angle theta passes through the point -3 and -4. So -3 is X and -4 is Y. Who can tell me where is this angle is? Since the terminal side passes through this point, where it is? In which quadrant?
3.
In the third, because X is negative and Y is negative. So if you want to sketch the angle, here it is like this. Here is the point. Okay, if you want, you can draw it -3 and -4 like this. You can say this is -3, this is -4, but this is not the length of the side, Shabab. These are the coordinates of the point. And you can find R here. What will be R, by the way? R will be the square root of this one squared plus this one squared, square root of 25, which is 5. So R is always positive. So now you have X, you have Y. Find R. This is R. Halas, now you can find whatever you want. Sine will be what? Sine will be Y over R. Y over R. -4 over 5, which is -4 over 5. Don't write, Shabab, the negative in the denominator. Never ever write it in front of the number or in the denominator. Similarly, cosine will be X over R, -3 over 5. And you can also, some of you, ya Shabab, they still prefer the triangle. If you want, yes, continue, why not? But I don't recommend that. Just find X and Y and continue. Any question, Shabab? Because now we will take the last, I think, exercise in this type of problems. Now, find the 6 trigonometric function values for the angle in the standard position if the terminal side is defined by this line. He didn't give me a point. He gave me the equation of the line. Okay? So now how to solve such problems like that? And this condition is important, Shabab. Without this condition, it will be difficult for us to decide. Let's see. Now, what is this line, Shabab, is? X plus 2y equals to 0. This is X. Let's solve it for Y. To understand better, solve it for Y. So it will be Y equals to -half of X. Is this, Shabab, does this pass through the origin? If you sketch the figure, when X is 0, Y is 0, so it passes through the origin. Now, if you draw this line, Shabab, is it increasing or decreasing? Is it going this way or this way? What is the slope, Shabab? Look at the slope. The slope is what?
Negative.
Negative, so it is decreasing. And decreasing and passing through the origin, it will be like this. Something like this. Now, this condition X greater than 0, it means that you will take it in one quadrant, not in two quadrants. So what do you think? X greater than 0, here or here? Where is X is greater than 0? This is 0, Shabab. Here X is greater than 0. So we will not take this part. We will just take this part. Now, where is the angle, Shabab? The angle is in the standard position. So this is the initial side. So the angle is like this. And this is the terminal side. So the terminal side of this angle is in the fourth quadrant. In the fourth quadrant. I wish that this is clear. Now, this is the angle theta, Shabab. Now, how to find sine and cosine and so on, ya Shabab? We need to take a point on this line. Any point, any point. Can we take x, for example, equals to 1 and then find y? This is one way. So we can we take x equals to 1, ya Shabab? Yes, because x is greater than or equal 0. For example, you cannot take x to be negative. X, if you take, let's say, x equals to -2, this is not right, because he said here x is positive. So, but ya Shabab, what is the best value to take here for x to find y? If you take x equals to 1, y will be -1/2. It is not good, not bad. Also, it is not good because it is a fraction. It is better, ya Shabab, to put x equals what? 2, to cancel this 2. Then y will be what? -1. So this is, I think, nicer, ya Shabab. Now it will be easier for you to find r. Here, when you find r, you have fractions. So try to avoid that. So now finding r will be so easy. Look, r will be what? The square root of 4 plus the square root of -1, which is 1. So it will be the square root of 5. If you choose another x with another y, you will have another r, ya Shabab. Because here it is the ratio, the distance from the origin to the point. Let me explain that again in the next slide. So we can use here any point on the terminal side, of course, except the origin. If we choose the origin, there is no r will be 0. This is not the case. Now, what we will do, we will choose x to equals to 2. This is the best x, as I told you. Now, what you will do, you have x equals to 2, y equals to -1, and this is clearly shows that you are in the fourth quadrant, and r is the square root of 5. Now you can find whatever you want. You can find all the other functions: sine, cosine, just x over r, y over r, y over x, the tangent, and the remaining are the reciprocals. Is it clear, Shabab? Any question?
Clear, Mr. Clear.
Good. خلاص يا شباب. I forgot to mention, ask you something. What was the line that we had here, يا شباب? Is -1/2 x. Is that right? Because here we solved this one for y. What is the slope of this line?
-1/2.
-1/2. Look at sine, cosine, tan, cotan, secant, cosecant. Which one of them is equals to -1/2? This one.
Tangent.
Why is that? Why is that, ya Shabab? Let's see. So this, what we have here, we have a line here. We have an angle. This is the terminal line. Now, you know, ya Shabab, if you have a point here, x and y, and the point here is 0 and 0, the origin, how to find the slope? The slope will be what? Y minus 0 over x minus 0, which is y over x. So what is y over x? You remember the definition of tangent? It is the tangent. So what we conclude here, that the slope of the terminal side of theta is equals to the tangent of theta. And this is interesting. And this, of course, you should consider this when you solve some problems. It will save your time. Now, we are, yes, please.
What does it mean when you say the terminal side of theta? Does it mean when the point is on the y-axis and the x-axis?
No, the terminal side of theta, if you have angle, this is angle.
Oh.
This is the terminal side.
Okay.
So the slope of this is tangent theta. Like the previous example here. Look here. This was the line, the terminal side. The slope of this line is -1/2, which is the same as the tangent of theta.
Yeah, okay, I got it.
Now, ya Shabab, the most important part in this section is here. Okay, the reference angle. Do you remember my question that I told you about how to find, for example, the trigonometric functions for this angle because it cannot be in a triangle. So how to do that? Now we will be able to do this. We will, with the help of the reference angle, we can find, of course, the trigonometric functions for any angle. Now let's start with what is the reference angle. So let theta be an angle in standard position. The reference angle theta bar associated with theta is acute angle. What does that mean, Shabab? This means that it is positive because all the acute angles are positive. So it is positive, not negative. So what also, ya Shabab, we understand from the word acute, it is less than what?
90
degree.
So it is less than 90 degrees or less than pi over 2. So to combine these together, we will say that theta is less than 90, greater than 0. So this is the meaning of acute. Okay? So it is acute angle formed by the terminal side of theta and the x-axis, and this is also very important. It is between the terminal side and the x-axis. I think this is clear, not the y-axis. Be careful. So now let's try to use this definition to evaluate it. What is it? So to find it. If we are in the first quadrant, ya Shabab, if we are in if the angle is in the first quadrant, what will be theta bar? Where is when we have acute angle, acute, is this acute angle, ya Shabab, here? This one is acute. But is it between the terminal side and the x-axis? No, because it is between the y-axis and the terminal side. So this is not the reference angle. So where is the reference angle, Shabab? Who can give me a acute angle between x-axis? This is x-axis and the terminal side. Where is the angle that is between the terminal side and the x-axis? What is it? Theta itself, ya Shabab. So in the first quadrant, the reference angle is the same as the angle. It is the same angle. So indeed, if you have angle in the first quadrant, no need to talk about the reference angle because it is an angle inside the right triangle. No need. It is acute. Now, if we are in the second quadrant, wake up, ya Shabab. I will ask you one by one, by the way. If you didn't respond, try to participate, ya Shabab. Now, if we are in the second quadrant, ya Shabab, where is the acute angle that is between the x-axis? This is the x-axis. I mentioned it. It's okay. It appears. So this is the x-axis, ya Shabab. This is the terminal side. So where is the angle that is acute and between them? Here it is. Not this one. This is not one because this is between the y-axis, not the x-axis. Now, the question is, what is this? How to find it? How to evaluate?
Subtracting the theta.
Okay, Shabab, what is this?
minus pi.
This angle, Shabab, this angle is straight. This one, the whole one here, it is straight angle. It is 180 degrees. So to find this, you will subtract this. I need this, only this one, this part. So what I will do, I will subtract from 180, I will remove this part from here. So what is remaining, if I remove this part from 180, I will get this. So the theta bar is 180 minus theta. In radians, this is pi minus theta. This is if we are in the second quadrant. Okay? If we are in the third, this is the reference angle. Is that right? This is theta bar. Am I right? Is this correct? No, because this is not between the x-axis. We are talking about the x-axis and the terminal side. So the acute angle between them is this one. Not this one. This one is not acute. So here, this is theta bar in this case, ya Shabab. This is theta bar. Now, how to find theta bar, ya Shabab? How to find the value of this? We will remove this part from this theta. So we have here, from here to here, we have theta. We will take this part from here to here, which is 180 to have theta bar. So in the third quadrant, theta bar is theta minus 180 degrees. In radians, theta minus pi. Similarly, in the fourth quadrant, it will be what? In the fourth quadrant, it will be all of this, subtract theta from it. So it will be, in the fourth quadrant, it will be 2 pi minus theta, 360 degrees minus theta. So this is what you need, ya shabab, to remember. You can summarize it in one chart. In the first quadrant, theta bar is the same as theta. In the second, it is theta bar equals to pi minus theta. In the third quadrant, theta bar, it is theta minus pi. In the fourth quadrant, it is 2 pi minus theta. And I think this is so clear. Okay. Let's take now an example. This is the warning that I told you about. It is a positive acute angle that is with reference to the x-axis, not the y-axis. Let's find the reference angle for this one. Theta equals to 5 pi over 3. I know, ya shabab, most of you, they prefer to convert this to degrees. So what they did, what is pi over 3? It is 60 degrees. So this is 300 degrees. In which quadrant is this one, ya shabab? This angle in which quadrant?
Fourth.
This is in the fourth quadrant. So because it is in the fourth quadrant, what is theta bar? Just remember what we said here.
360 minus 300.
So it is 360 minus 300 degrees, which is 60 degrees. But ya shabab, he gave you the angle in radians. So your answer, your final answer should be also in the radians. So what is 60 radians? Pi over 3. This is, ya shabab, what most of you prefer. But when I give you, for example, 17 pi over 5, it will be difficult, ya shabab, for you to convert to degrees, and then so it will be a headache. So I don't advise you to convert to degrees. So what you need to do, ya shabab, is to deal with the problem as it is. 5 pi over 3, you know that this one is less than 2 pi. Why is that correct, ya shabab? 5 over 3 is less than 2. Also, this one is greater than 3 pi over 2. Why? Because you know, ya shabab, what we have. This is 0, this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi again. So here, I expect that this one is it is bigger than pi, it is bigger than pi, clearly. So it might be in the third or in the fourth. How to check? Compare with this. You know, ya shabab, that 3 over 2 and 5 over 3. Which one is bigger, which one is smaller? To know, do cross multiply. 3 times 3 is 9, 2 times 5 is 10. So 9 is less than 10, so 3 over 2 is less than 5 over 3. Okay? So what is the meaning that it is greater than 3 pi over 2 and less than 2 pi? This means that this one is in the fourth quadrant. So how to solve this, ya shabab, from the beginning without converting? You will say this. 5 pi over 3, which is theta, it is belonging to the fourth quadrant. Why? You will mention here that it is between 3 pi over 2 and 2 pi. Now, because it is in the fourth quadrant, what will be theta bar? Theta bar will be 2 pi minus theta. So it will be 2 pi minus 5 pi over 3. What is it, ya shabab? 2 times 3 will be 6. 6 minus 5 is 1. So it is pi over 3. Look now, which of course solution here is shorter and nicer. It is when you deal with it as the radian. Excellent. Now let's go to the second one. 870. In which quadrant, ya shabab? 870 degrees. In which quadrant this angle is? Hello, 870 degrees. You can tell me we don't know because it is greater than 360. Is that right? So if we have an angle, ya shabab, that is greater than 360 or less than 0, we need to do something before. What we should do at the beginning before going further, ya shabab, we should subtract 360 twice. So we should subtract 270 to get what? What we will
150.
150. What is this? This is a process, ya shabab, it has a name. What we did here?
A reference point.
No, this is not the reference. This is
Terminate.
co-terminal. Yes, this is co-terminal. What we did here, Shabab, if we have angle that is greater than 360 or less than 0, we need first to find the smallest positive co-terminal angle with that angle. So this is the smallest positive co-terminal angle. Okay? So now this is of course Shabab theta. So we canceled the rotation. Now this one in which quadrant, Shabab? In the second, clearly. In the second, it is between 90 and 180 degrees. So what will be theta bar in this case? Theta bar will be what? In the second quadrant, it will be 180 degrees minus 150 degrees. You know what is it in the second. So this is equals to 330 degrees. So what is this angle, the reference angle of this angle is 30. So this means, ya Shabab, what is the meaning of that? It means that the sine or cosine or tan or cotan of this angle is the same as this. Maybe just they have the same value, but maybe they diverge in signs. It could be positive or negative. Just this is the only difference. Let's see that in the next example here. In this example, we need to find cosine 135. And I told you this is now how to do that. How to do that? Ask yourself this question. Is this less than or greater than 360? If it is between 0 and 360 is okay. No need to find the coterminal. If it is between 0 and 360, find the reference. Now, you need to ask yourself, in which quadrant is this angle? This angle in which quadrant, Shabab? This is in quadrant number 2. Is that right? So how to find, Shabab, the reference angle if it is in the second? It will be 180 degrees minus 135 degrees. Now, do you remember in the second quadrant, cosine, is it positive or negative?
Negative.
All STC. So here, what is positive? Sine and it's reciprocal. So it is negative. So write here negative. What does that mean? It will be negative cosine 180 degrees minus 135. It is 45. So this means, ya Shabab, that it means that the cosine of this angle is the same as cosine 45, but 45 is in the first quadrant. It is positive. But 135 in the second, so it will be negative. What is cosine 45? Square root of 2 over 2. So its cosine is the same as the reference angle, but with negative because it is in the second. Yes, any question, Shabab? I heard someone talking. Let's take the next example. It is interesting to talk about this now. Tangent of 390. Now, when you find tangent of 390 degrees, you should ask yourself first, is this between 0 and 360 or not? It is not. So it is greater than. So what you will do, you will find the coterminal. So you will say this is equals to tan, no positive or negative when you find the coterminal, because they are, of course, periodic. Now, what you will do, you will just subtract 360. I will mention this later, Shabab. Of course, when we add or subtract 360, we have the same angle. We are at the same quadrant. We don't go to another quadrant. So this is why no positive or negative sign is needed here. Now this will be equals to tan what? Tangent 30. 30 is in the first quadrant, so it is the same as its reference. Khalas, done. What is tan 30 degrees? What is tan 30 degrees? Ya Shabab. Turkey Zahrani. What is tan 30? Do you know?
1 over root 3.
Yes, you're right, which is of course square root of 3 over 3. Thank you, Turkey, and thank you, guys. This is all what we have for today. We will continue. We will continue, inshallah, next class on Sunday. Have a nice weekend, and don't forget.